All right, here we are taking a look at this in class. We started this last class period, but we are going to finish it. So we're really using the calculators a lot, so follow along as we go over things. But you're taking these and you're going to graph their scatter plot, okay? Probably be a good idea. You could just like draw them on the side or get a different piece of paper to draw your scatter plots and just kind of sketch it. Doesn't need to be perfect. And then you're going to also find the correlational coefficient, okay? Now, the correlational coefficient is that number that tells us exactly how correlated things are. Remember, generally we speak of either a positive correlation or a negative correlation or no correlation, okay? And you can either have a strong or a weak negative correlation or a strong or a weak positive correlation, okay? And so we're going to see which numbers do that, what they tell us, that correlational coefficient. And that correlational coefficient we're going to use technology to find it. Can't speak apparently. Okay, and generally the correlational coefficient is represented with the R variable. Okay, so using your calculator, you're going to take a look at each one of these sets on the calculator, and then we're going to keep going and answer some questions. So we'll kind of jump back and forth from the calculator and not using the calculator to do that. Okay, taking a look at this connect the dots, and we're doing a lot of our stuff on the calculator because we need we've got set A, B, C, D, E, F, and G. So we've got 7 different sets that we are going to do a scatter plot for, find the correlational coefficient with the calculator, and we're going to go from there, okay? So let's get after it. So first thing we need to do is start a new document, okay? We're doing lists and spreadsheets, as well as, if we hit Control Doc, data and statistics. Okay, data and statistics to graph it, lists and spreadsheets to write it. So I'm just going to call this A, and that'll be the top row. B will be the bottom row. Okay, because we're working with a table or 2 different variables, okay, there's a few things we need to know. So as I go through and I write them out in my table, okay, these are all from set A, the top part. The thing I have to pay attention to is making sure that when I write my second one that our data sets match, okay? So if you look at that set A on your paper, it has 2 and 1, doesn't it? Okay, so those 2 need to be together. They're going to form a point on our scatter plot, okay? And if you mess those numbers up, it's going to mess up the whole thing. So as you can see, I did the first 5 and made sure that they were matched up, okay? But as long as I just, when I enter it in, okay, I just make sure to do it in order and then just double check after. Generally, you're going to be fine in putting in your data, okay? So finish putting in my data. Making sure to match them up. Okay, and we get that. So that's my data. Now if I want to take a look at the graph, I hit that right here. I go to the bottom there and I click on that variable, and we'll make the A set our X variable. You could do either one, but typically the top of a table is the X value. Hit enter. Now before, that's where we stopped, right? But now we're going to go over to this left side and click to add the variable, and now we make it into that scatter plot, okay? And then based off that we can come up with, you know, the correlation. Okay, is it no correlation? Does it look like it has a positive or negative? If I look at this one, kind of has a positive to it, but how am I going to tell if it's weak or strong? that's where that correlational coefficient comes into play. So to get the correlational coefficient, we go back to here. We're going to hit Menu, Statistics, Stat Calculations, and we're going to go to two variable statistics. And sometimes that does that. Okay, then we hit Enter because we're dealing with two variables. So now I've got to show it what those two variables are. So I click on there, and I'm going to choose my A because that was my X. So I choose A, then I go down here and choose B. Okay, and that's really all I need to worry about. Make sure it's not in the going to override a column. Then I hit OK, and then it's going to give me a lot of data that I don't necessarily need. The stuff with the X's, that was our A column. Okay, then notice it goes to the Y column, but we don't need to worry about those. There's them together, added together. What we need is this one right here, the R variable. That one's called our correlational coefficient. Okay, and that coefficient, which generally we round to the nearest hundredth, so that 0.49655, we'd probably could round up to 0.50, because if I round up that 9, right, it would make it into 0.5. Okay, that's that correlational coefficient there is what tells us what we've got going on. Okay, let's talk about what that number means now. Okay. All right, so we've got that graph, right, and the correlational coefficient for set A. So again, this is set A. There's what our graph looked like. So we can see it kind of has that positive, and it looks a little more, to me, it's kind of spread out, especially down here, so I'd probably call it a weak positive. But we did find that its correlational coefficient was like 0.49655, right? Which said we said we could round that to 0.50. Okay. So when we're talking about the correlational coefficient, here's the way to think about it. So if we don't have a correlation at all, then it's like it's got a correlation of 0. Okay, its correlational coefficient would be 0. If we're talking about positive numbers, okay, the most perfect correlation, something that was a straight line like this, okay, would have a correlational coefficient of 1. That's like the maximum we can have. Okay, so from 0 to 1, we're going to get that number. Right here we got 0.5, right? So 0.5 would be right here in the middle. From 0 to 0.5, that's where we would call it saying it has a weak correlation. Beyond 0.5 until we get to 1, that's when it has a strong correlation. So if we look at ours, it was slightly less than 0.5, so it would have a weak positive correlation. However, it's getting pretty close to being strong. Okay. On the negative side, same exact thing. If we go negative 0.5 and negative 1, we're going to have our negative, right? And negative 1 is that perfect straight line correlation going negatively. Okay. Again, that 0 is no correlation. So a weak negative will be from 0 to negative 0.5, and then beyond negative 0.5 to negative 0.1, or negative 1, would be a strong correlation. Okay? So looking back, we can say here, we've got an R value of 0.50, and so we're going to call that a strong, or not strong, weak, sorry, a weak positive correlation. Okay? So let's take a look at the rest. So picking up where we left off, this is set A still, right? And if you'll notice, set B, actually the A column, right, stays the same. Okay, those numbers didn't change at all, which looks like on set C and D and even E, those ones don't change, which will make it a lot easier. So we're only changing some of the B, or maybe all of the B. So if we look through, it looks like I don't change till I get down to 5.5. We change that one to a 4, and this is set B now, then 4.8, then we change this one to a 5, and then this one to a 4.6. Okay, so then we go back to our graph, and let's see how that changes things. Okay, so now if I look at this, it's even more strong to me. It's actually stronger because it looks a lot closer together. But let's check that correlational coefficient, right? Because that's the one that matters. So menu, statistics, stat calculations, to variable, choose A. Oops, too far down. Then I choose B. And we go down till we get to OK, hit OK. And then I'm going to scroll down till I get to that R, because that's the one I care about. So look at this one. Notice now we've got 0.935, so we can round that to 0.94. Just like we said, that's really close to 1, so that's going to be a strong positive 1 for us. Okay? So we put that down on our paper. All right, so we've taken a look at, so there's set B. We said it had a correlational coefficient of 0.94, which is definitely going to be a strong positive. Okay. Then we did set C. Next, and let's see what we get with that one. Now, here's the really cool thing, that because I know I'm just changing some of these, I can go and do set C and D without changing things, and it'll actually change that correlational coefficient and all that stuff that I already did. Okay. So on set C, we got 4.7. Looks like most of these numbers change, right? 4.9, 4.2, 3.9, but my A column stays the same, 3.5, 3.2, 3.1, 2.6, making sure I'm looking at the right thing, 3.2, and you should be following along with your paper and your calculator as well. Then 1.3 and 0.8. Okay, hit enter. Now we go back here, and we can see that our correlational coefficient has now changed. Notice it's a negative now, so it's a negative 0.94. Okay, so we know now it's going to change our graph, isn't it? And look, it did. Now our graph is pointing down. Okay, so that's pretty cool. And there's that one. Now let's see, set D I think changes a few of these ones. Let's see how that affects them. So we see that this one, right, now is going down in a negative, and it has almost an exact similar correlational coefficient as set B, but in the negative. So now it's a strong negative, right? Okay, let's take a look now at set D. Okay, so set D now, looks like we changed this one to 3.6. Then we got 2.8 for the next one. So we are changing a few here. Then 3.2, then 4.5, then 1.7. Oops, not 17. That would really throw things off. 1.7. Okay. So set D, then 3.7. Then 2.1 stays the same, 1.3, and 1.8. Okay. So hit enter, go down, see that correlational coefficient. And this one now we've got a negative 0.81. Okay, so not quite as close to negative 1 as negative 0.94. And we can see that on our graph now it's a little bit more spread out. Still strong because it's closer to negative 1 than it is to 0, but not quite as strong. Okay, so just those few adjustments made that difference. So here's our scatter plot for set D, right? Still going in that negative direction, okay? But we found the correlational coefficient as a negative 0.81, so still in that strong area, right? Because remember, it's still that strong negative, because it's between negative 0.5 and negative 1. Right, because if we look at that, we've got the that 0.1, negative 0.81 right here. Okay, so now let's take a look at set E. Now set E, okay, we go and make even a few more changes, don't we? So we go all the way up, and we've got 4.7 again, but then this one becomes 4. Then we've got 4.2, then 3.9 stays, then 2.8, then 3.2 again, 4.5, 3.7, 3.2, 4.8, 5, and 4.4. We go down to our correlational coefficient. Now that's not 0.6997, that's 0.069, okay, which we could say 0.07. So that one's really close to 0, and it's positive. So that one's gonna, let's look at what that does to our graph. And you can see now it's kind of more of a horizontal shape. It doesn't quite have that any sort of direction, which is why we're getting really, really close to no correlation. It has a very, very weak positive correlation, but honestly, we could get by probably calling this one no correlation as well. Pretty interesting, just changing a few numbers, how different that can look. This one now didn't really have a whole lot of direction going to it, did it? Okay, almost looks horizontal, and we found that we had a correlational coefficient of 0.07, which would make that either very weak positive. You could even argue that that's really close to 0, and then that would be a no correlation on that one. Okay, right, because that is really close right here, that 0.07. We also had the negative 0.94, positive 0.94, and then the positive 0.5, right? And that was set A, B, C, D, and E. Okay? So, there's set E. Let's take a look at the next one. Now, for set F and also G, now we're actually getting rid of some of our numbers, aren't we? So what we can do is we can just delete from the bottom up, okay? So it looks like we don't have the 6.4. See, and it doesn't like that. See how it said that mismatch? Let me show you again. See how it says that dimension mismatch, 2 or more arguments must have been matching dimensions, okay? That means that you can't make a scatter plot unless they're all unless you have the same amount. So we're going up here to 5 because the rest are the same, right? So we've got 2, 2.3, 3.3, 3.7, 4.2, 4.6, 4.5, and 5. Okay, so we can erase those. Notice how that one made a line. You do need to delete that, or else it'll think something should go there, and that happened when you delete it that way. Now we can change these, right? So this is 1.8, 2.22, 3.62, 4.18, 4.88, 5.44, 5.3, and 6. But notice, see, we had changed from 12 to 8, so it's still, and notice that, but we go down here, our correlational coefficient now is exactly 1, okay? So that's that kind of perfect version, and what does that look like? It looks like a pretty decent straight line, doesn't it? Okay, we've got the points clear up there at the top, right up there, okay? But we can see that that basically makes a straight line. So yeah, so that correlational coefficient of 1 would make it look like that. So set F, we had that, we could draw that straight line, so it had a correlational coefficient of 1, so definitely a strong positive. which would put it, you know, right here. This was f at negative, or not negative 1, positive 1. Why did I say negative 1? All right. Okay, let's look now at the next one. All right, so now let's do that last one. Okay. So this becomes 4.4, 4.01, 2.71, 2.19, 1.54, 1.02, and so on. Okay, we go down to our correlational coefficient, and now we see we have a negative one. So that's going to look like a straight line, but going negative, right? So that's that perfect negative, and you can kind of see if we go down here, there's barely that little dot right there. Okay, but I kept them in the same window so that we could see what they all look like. So let's take a look at all these scatter plots together and talk about question 1 and 2 and kind of look at those, okay? For set G, we see that we've got now a correlational coefficient of -1, so definitely a strong negative, okay? See that line that it's going straight down like that, putting us right here at -1, and that was G. All right, now what they want us to do is to put them in order based on the correlational coefficients, okay? So let's do that. So, and then we want to compare each scatter plot with its correlational coefficient. What patterns do we see? So let's get ourselves an empty page and do that. So we got them all here, okay? So A, B, C, D, E, F, and G. Okay, we kind of organized them in order here, didn't we? No, that was not our bell to get out of class. Okay, so G, that -1, and then we go to F, the positive one. Okay, so -1 would be right here. Okay, so that's going to be our first one, right? Okay, so that's -1. And maybe what we can do is offset them a little more. Okay, now what would be the next negative? Well, we look back here and it was that -0.94, which was C right here. Okay, so maybe put that one right there. That was -0.94. Okay, then we've got our other -1, D, right? So that'd be this guy right here. Okay, and that was -0.81. And actually, let's scoot these even more. Let's make them go kind of like this. Okay. Then we had our almost no correlation. That was the 0.07. Now we're going to build our positive ones, right? Which is probably pretty easy to see. But it's going to go kind of in that order, isn't it? So we had this one here, which was 0.5 exactly. Then this one here, which was 0.94. And finally, this one right here, which was our positive one. So we can kind of see from negative to positive, okay, perfect, strong, strong, no correlation, weak, strong, and strong. So if I wanted to put one here that was weak, you know, it'd go down, but it'd be even more spread out. Okay? All right, do we notice any patterns? Well, the closer it gets to 1, the closer to a straight line. The closer to 0, the less of a straight line. And going up positive or negative depending on if it's positive or negative. All right, okay. So there we go with those guys. Now let's take a look at 3. So now have your guest teacher pause on this one, and I want you guys to try to do this on your own. Okay, so what you're doing, you're keeping the A column. You're going to put your own numbers into B to try to get your correlational coefficient to be as close to 0.75 as it can be, and then answer this question. Okay, so we'll have them pause there for maybe 5 minutes maximum, since it is a short day today. So yeah, let's do that. So pause this video right here. Alright, so we've got our A column in there already. It's the same one we've had. So if you still have some B column numbers, you are great. You can just do those. And remember, we're trying to get to 0.75 for our correlational coefficient. So let's just say we try some just random numbers here. And I'm actually just counting up, aren't I? Okay, so let's see what kind of thing that gets us. Now, I can take a look at the graph if I want to, right? Why is this not working for me? There we go. So click to add A, click to add B. It's a pretty straight line, right? And remember, it's 0.75, not negative 0.75, so I do want a positive. So let's see what that gives me. So I'm going to go now and hit Menu, Statistics, Stat Calculations, to Variable. Tell it I want that A, that to be B. Okay, then let's go down to our correlational coefficient. And we got 0.98. Okay, so that's too high, isn't it? So I'm going to have to spread this out a little bit. So maybe if I made this a smaller number, and I can look and see how that affected it as I change. That's kind of the cool part. So, okay, as I make this, some of these, some smaller numbers, 7, okay, 0.95, so I've probably got to do better than that. Okay, so 0.56 now. So now I'm too low, aren't I? So maybe if we move this one up a little bit. Ooh, 0.766. Okay, I'm getting pretty close to 0.75. So we can see, what did that do to my graph? See how now it's kind of spread more out in that area? Okay, and maybe I go and make that 4, make that 5. Okay, 0.755, maybe 8. Oh, that one's pretty good. Okay, so I'm going to go with that one right there. And we can see that I got the 0.75, so pretty close. There's my graph. So what did I have to do to get it a greater correlational coefficient? Was to make it more in line. To get a less coefficient was to make it more spread out, right? So that's what you should have got on number 3. Something like that. You could have had a completely different looking graph and still ended up with that similar correlational coefficient. All right, so now let's take a look at number 4. On the night before the last math test, Shaniqua held a study group at her house. It was a great night. They ate a lot of pizza, did math, and laughed a lot. Shaniqua scored better on her test than usual and thought it might be related to pizza. She collected the following data from her friends in the study group. So, number of pizza slices per person, and then, right, and then the increase in the test score. So what you're going to do on your own, and we're going to pause it a little bit again, is you're going to create a scatter plot, calculate the correlational coefficient, and tell me, would you recommend them eating pizza? Okay. Then try to answer 5 and 6. We'll give you about 5, maybe 10 minutes, depending on how much time you have left. So pause the video now and work on this. All right, so hopefully you were able to answer some of these, but so let's take a look at them on the calculator. Let's create that scatter plot and go from there. So this problem, so we go new document, right? If somebody already has something on there, we don't save it. We go to lists and spreadsheets. So we put in our data. So we've got pizza eaten, so let's put pizza here. And then we've got test scores, so let's put test. This is an increase in their test scores, not just that. So then we enter in our data for Shaniqua 2 and 5, and you can enter in one at a time, or you can go down the list. So David 6 and 9, then Susan 1, Ruby 4, Dion 3, and Oscar 5, and test scores Susan 4, Ruby 7, Dion 6, and Oscar 8. Okay. So now we want to do the scatter plot and find the correlational coefficient. Okay, I'm going to do the correlational coefficient first. So menu, statistics, stat calculations, to variable stats, then pizza for my x, and test for my y. Okay, put it in the D column. Okay, and again we want to go down, right, till we get to that R. Okay, so correlational coefficient of a +1, which tells us that's a good thing, right? That is definitely a good thing. So let's add our data and statistics, or go to it. Click down here, pizza, here, test, and there's our graph, right? So what does that tell us? Well, that tells us that with that correlational coefficient of 1, that there is a positive correlation, that the more pizza you eat, the higher you're going to do on a test. So, based off this data, would we recommend eating pizza to increase test scores? Why, yes. Yes, we would. Okay? Because that's what the data is showing us. Okay? That correlational coefficient tells us that that's a good thing. Now, if it were the opposite way, then that would be completely bad, and it would be the opposite. The more pizza would hurt you. So, describe a situation where two variables that may have a high correlation but not be causally related. Okay? So in that, we're looking at kind of like pizza and a test score. Okay? Honestly, that's really not a correlation. Okay? It could have a high correlation, but they're not related. Okay? They're not going to be things that make us do one thing or another. Okay? Another example could be the amount of ice cream eaten and the number of drownings. Okay? There could be a high correlation, because when do we eat more ice cream? In the summer, when more people go swimming, especially in places where there's not lifeguards, which would cause more occurrences of drowning. So they could be correlated, but they're not related to each other. They're related to more the time of the year, the temperature where you're at. Okay? So what are some reasons that two variables may be highly correlated but not have a causal relationship? So there's that. There could be a third factor, like we just kind of mentioned, something that is causing both to be higher than the others. Okay? All right, guys. So you've got the homework to work on with the remaining class period, and get it done and hand it in. When, probably not this class period, but next time, get it done and hand it in. And there we go.